All right, we're back at AP Review. This is 2015 AB Free Response 6. Consider the curve given by the equation y cubed minus xy equals 2. It can be shown that the derivative dy dx equals this, y over the quantity 3y squared minus x. Thanks for doing the derivative for me, AP. Part A, write an equation for the line tangent to the curve at negative 1, 1. Okay, so when we go to do part A, right, no matter how hard math gets, when you're asked to find the equation of a line, right, if you're asked to find the equation of a line, you need exactly two things. One, you need a point. Well, they did you a solid here, and they told you the point was negative 1, 1. So yay, thanks, AP. Two, you need a slope, right? But since tangent slope means the derivative evaluated at the point, that means you need to evaluate your dy dx at negative 1, 1, which you can do because they gave you dy dx. Again, thanks, AP. That was super cool of you. So when I plug this in, I get a y over 3 minus a negative 1, so 3 plus 1. So I should end up getting a 1/4 as my slope, right? So I'm like, hey, that's pretty cool, AP. You gave me a point and you gave me a slope. That means that I just have to write my answer in point slope. So y minus the y value equals m, 1/4, x minus the x value, right? And that answer is legit, absolutely, completely, and totally fine. If you want to solve for y because you just absolutely feel the need, I would not distribute the 1/4. I would just add that 1 over to the outside, right? Either of those answers are fine. They did not ask you to solve for y, so either of them should be fine. Part B. Find the coordinates of all points on the curve at which the tangent line to the curve is vertical. Cool. So this requires a little bit of translation. So you need to know a couple things, right? So the first thing you need to know is what a vertical tangent line would mean, right? So a vertical tangent line, right? So if that's what they're asking for, right? A vertical tangent line means that dy dx is undefined, which if we take a leap farther from that, that's saying that the denominator of dy dx equals 0, right? So I need 3y squared minus x to equal 0. So 3y squared has to be x. Well, the reason that's the easiest, that's where I'm going to stop right now, is I can't solve this equation by itself because it's two variables and it's a single equation. However, they asked me for points on the curve, right? I have to have points on that curve. So that means they have to work with this original equation. So now what I'm going to do is replace the only x I see in here with a y, 3y squared, and then I'm going to be good. So y cubed minus, instead of an x, I'm going to put a 3y squared times a y equals 2. Well, I'm pretty sure that's y cubed minus 3y cubed equals 2. Negative 2y cubed equals 2. So y cubed is a negative 1, which means y is a negative 1. Once I know the coordinate of the y, I can go back and find the x coordinates, because I know that x is 3 times y squared, which means that x has to be a 3, right? So I end up getting that my answer is just the 1 point, 3 comma negative 1, right? That's the only possible point that gives me that. So again, it took you knowing that a vertical tangent line means that the derivative is undefined, which means the denominator is 0, which gives you this first equation. And then you have to remember that it has to be a point on the curve, so you have to substitute back into the original equation. Part C. Evaluate d squared y dx squared at the point on the curve where x is negative 1 and y is 1. Cool. So I can't evaluate d squared y dx squared unless I find d squared y dx squared. So I guess that's the next thing I have to do. So we know that dy dx is a y on top of 3y squared minus x, right? Double check that I copied that right. Cool. They want me to find d squared y dx squared. So what they're asking here is for me to find d squared y dx squared and evaluate it at negative 1, 1. That's what they want, right? But I can't do that without finding the derivative first. So when I derive this, d squared y dx squared, right? Now I'm going to have to do the quotient rule because this has a high function and a low function. So low d high is going to be a dy dx, right? Derivative of y is a dy dx, minus high, which is a y. D low is going to be a 6y dy dx minus a 1. Draw the line, square the low. quantity squared. So now, that's great. I wouldn't clean it up if I were you. I mean, you can, but it's not a good choice, right? The reason I'm not going to clean it up is they didn't ask me to find an equation for this thing specifically. They asked me to evaluate it at negative 1, 1. Also worth noting is that from part A, we know that dy dx evaluated at negative 1, 1, because that was the same point, was a fourth, right? We got that in part A, that dy dx evaluated at negative 1, 1 was 1/4, because that was the tangent slope. So anywhere I see a dy dx when I plug in the values, I'm just going to cheat and plug in a fourth. So I get d squared y dx squared evaluated at negative 1, 1 to equal, now remember I'm plugging in a 1 for my y and a negative 1 for my x, right? So we actually already saw that this denominator comes out as a 4, right? Because it would be a 3 minus negative 1. So anywhere I see a 3y squared minus x, I'm just going to remember, oh, hey, that was a 4. dy dx was a 1/4, right? Minus y is a 1. This would be a 6 times a fourth minus a 1, all over what seems to be a 4 squared, right? So I get here, and there's a chance you're going to mess some math up, but you just do your best to try and clean it up. So the 4 times a fourth is going to be nice. This is going to be a 1, right? This is a 3/2 minus a 1. So that's a 1/2. So I get 1 minus a half on the top, and on the bottom I get a 16, right? So the top is a 1/2 divided by 16, which is the same as a 1/2 times 1/16, so your answer should be a 1/32, right? Sometimes it falls apart at the end, not because the math is particularly difficult, but because calc people are more likely than most to make simple addition or multiplication errors. I don't know why. I think the better you get at hard math, sometimes the worse you get at the simple math.